Hi there, what's up everyone? I hope you're doing well. So if you've been following my series on ray tracing in C++ using only the standard libraries and the SDL2 library to display results in a window, you'll know that I've been putting together a simple ray tracer that I've called qbRAY. qbRAY is a simple but fairly fast ray tracing implementation and is available over my GitHub repository if you want to go and check it out. Alternatively, you can go through the episodes of the series, 27 of them so far, and build the whole thing yourself, if that's your thing. In this video, I'm going to be adding to the modeling capabilities of qbRAY by adding support for constructive solid geometry of ray-marched shapes. One cool feature of qbRAY is that it allows ray marching to be combined with ray tracing, and even path tracing, though not in the publicly available version yet, so we can build complex shapes by controlling how we form the signed distance functions. I'm not going to go over that, as I've covered that already in another video. There'll be a link in the description below, but instead I'm going to jump right into modifying the qbRAY code to support simple union, difference and intersection operations applied to the signed distance functions for ray marching. So let's go. Right, the first thing I'm going to do is to create a new scene class called RayMarchTest. So we'll create raymarchtest.hpp file first. This will inherit from the existing scene base class that we already have, but let's skip through the includes and so on. To start with, I'm just going to include the sphere shape from the ray marching library. Obviously we don't need to use ray marching to make a sphere, but it does serve as a good starting point to set up our scene. I'm going to create a separate namespace for scenes, which will help to keep things organized. And our class will be called RayMarchTest, which inherits from scene. Once we're done with the header file, let's move on to the CPP file. So the main function here is setUpScene. It is here that we will create all of our objects and set up the camera and so on. We'll do the camera first. Next, we configure the ambient lights that we want. This isn't a path traced scene, so we need a constant ambient light. Then we're going to define any textures that we might need. In this case, we'll just need one, which will be a checkered texture. We'll need a material so that we can apply the texture to an object, so let's create an instance of the simple material class. Now, let's make an actual object, which I'm going to call ray shape for now, as it's a shape for testing ray marching. It will initially just be a sphere, so we can be sure that we've got the scene set up right before making anything more complicated. Okay, let's compile and make sure everything works. Okay, so obviously, I've obviously gone wrong a bit somewhere. The problem actually was here where I put a P instead of a curly bracket. And GT form, it should be not GR form. Fixing those problems, and now everything compiled, but we get the previous scene. So let's go to the capp.h file and include the new scene and make sure that we're using it. And we'll compile and run, and we should get a blank window. Indeed we do. So the first thing we need to do is to include our object into the scene. And we'll need to add some lights. I'm just going to copy and paste the code for those. If we compile and run now, we should see our sphere. Yes, indeed, there it is. However, it doesn't look quite the way I want. First off, let's look at scaling the texture better. And let's try a 1/2 by a 1/2. Okay, well that looked the same. So let's try 8 by 8, which is what I did put originally. Which is much better. However, the sphere still looks upside down. So this is because of the direction of the up vector for the camera, which should be +1 and not -1. qbRAY usually works with negative values corresponding to up. I'm not sure why I went with that now, but I've just stuck with it as a convention really. And there we go, a very simple sphere. That serves well as a starting point for looking at making more complex shapes with ray marching. Now, to make some more interesting shapes with ray marching, we're going to need to add some functionality to the sdffunc.hpp and sdffunc.cpp files. This is where we originally defined the distance functions for our common shapes, such as sphere, torus, and box. So, first off, in the header file, sdffunc.hpp, we're going to add a new namespace called combine. We're going to use this for all our functions related to combining different SDFs. We'll add functions for union, difference, and intersection. Right, so let's look at the sdffunc.cpp file. Here we need to define the functions for the union, difference, and intersection operations. These are fairly standard and very easy to do. So the union is just the minimum of the two distance functions. The difference is the maximum of one with the negative of the other. And the intersection is the maximum of both. We just need to include the algorithm header file as well. Let's compile to make sure everything still works. Right, with that done, we need to create a new shape in the qbRAY March subfolder called blob. We'll start with blob.hpp. We could have called it anything, of course, but I'm not aiming for a specific shape in this example, so blob will do. The blob class will inherit from RayMarch base. Our RayMarch encode relies on each object class implementing an object function that computes the signed distance function. So let's have a go at blob.cpp. qbRAY uses function pointers for this, so we'll create one for our object function, like so. We'll define a standard bounding box, making sure that we set the scale to 2 on each axis to make sure that everything will be inside it. We could take more care here, especially if we're making something really complex, to ensure that the bounding box aligned tightly with the geometry. So finally, we just have to create the actual object function. We're going to define 2 sphere shapes with different center locations. And we'll set the radius of both to 1. Then we just have to compute the distance according to the spherical SDF for each sphere. We'll call these dist1 and dist2. And then we return the final distance, which is the result of some kind of combination of these two. We'll start with union. Let's compile and see what we get. Okay, so I've made an error with the brackets here. Let's just fix that. And try again. Okay, so this was an easy fix. And one more try. There we go. Now let's modify the scene to include our new shape. We'll edit the RayMarch test.hpp file first to include the new shape class. Then back to the RayMarch test.cpp file. All we have to do is change sphere here to blob, and we're done. Let's compile and run. There we go, 2 spheres joined together by the union operation. Let's try difference and see what we get. There we go, this has subtracted the second shape from the first. And finally, let's look at intersection. And there we get only the shape contained within both spheres. So that's it for now. We've looked at how we can create a new qbRAY scene to explore some new shapes. We've created a new ray-marched shape class called blob, and we've implemented 3 common methods of combining different sign distance functions: union, difference, and intersection. You can play around with these as much as you like, using the basic outline that I've shown in this video to create all sorts of more complex geometry. Just remember to make sure that your bounding box for the shape class is always large enough for the whole shape, preferably without being too large. Okay, so that's probably enough from me for today. I hope you've enjoyed this video. I certainly had a lot of fun making it. If you have enjoyed it, then please remember to hit that like button, and if you haven't done so already, please consider subscribing to my channel so that you don't have to miss any future videos. Thank you very much. Anyway, I really look forward to seeing you in the next video soon. Bye!